Oh wow, didn't catch you there. Don't worry, I'm just, flipping through the Webster's Encyclopedia Dictionary. Oh wow, God, I'm such a nerd. But today we're gonna go over a more pressing issue. Have you ever just looked at a circle and wondered why the area is pi r squared? Because honestly, that really confused me, and I was too afraid to ask in class, and now it forever haunts me, and I'm in college, so yeah. Okay, let's take these three circles. Now let's divide one into fourths and one into eighths. When we rearrange the four quarters of the circle, we get something like a parallelogram. When we rearrange the eighths of the circle into a parallelogram-like shape, we see that the ends of the shape are becoming more parallel to each other, therefore more rectangular. This suggests that the more we cut the circle, the more the shape that we arrange it into will be rectangular. So if we cut it infinitely many slices, then the circle will rearrange itself into a rectangle. We know that the circumference of a circle is 2 pi r, meaning that half of a circle's circumference will be pi r, and the top of our edges of our rectangles will be pi r as well. We know the radius of a circle is the line from the origin to any edge of the circle, so the width of our rectangles will all be the same size of the radius of the circle. Since we know that the area of a rectangle will be length times width, and that our length will be pi r and our width will be r, we know the area of the rectangle will be pi r squared, and since the area of the rectangle is equal to the area of the circle, it will also be pi r squared. Now it's time for calc. Before we begin integrating, we actually need an equation to integrate. So imagine a circle on a graph with its center at the origin. Picking any point at the edge of the circle, we see that that point will have some arbitrary value of x and y. We see that this creates a right triangle, and we know by Pythagorean theorem that a squared plus b squared equals c squared, where c is the hypotenuse. We also know the hypotenuse in this scenario will be the radius. It's highlighted in orange. So from this information, we can see that x squared plus y squared equals r squared for any point around the circle. The equation y squared plus x squared equals r squared can be split up into two equations. Y equals square root of r squared minus x squared, and y equals negative square root of r squared minus x squared. For simplicity, we'll work with the positive equation from 0 till the edge of the circle. So I'm only integrating a quarter of the circle because when you're integrating an equation, you're just calculating the area under the graph. And so if we do that and multiply by 4, we'll get the area of the full circle. So with that, let's take the equation of the circle and integrate it from 0 to r and multiply it by 4. Then we're going to use u sub. Let x equal to r times sine of theta, and the derivative of that will be r of cosine. Now we're going to plug in r sine of theta and replace dx with r times cosine of theta times derivative of theta. You might have noticed that the limits have changed, and that's because we need the limits to be in terms of what we replaced x with, so in terms of r times sine of theta. So first we're going to set r times sine of theta to 0, and then we'll get that theta equals 0. And then we set r equal to r times sine of theta, and we get that theta should be equal to pi over half, making our new integral be integrated from 0 to pi half. After some algebra and the use of the trig identity sine squared of theta plus cosine squared of theta equals 1, we get this new integral. At this point, we're going to use another trig identity, and we're going to remove r squared from the integral. From the equation at the top of the page, we can see that we can just remove half as it's just a constant, and then separate the integral into 2. Next, we're going to just use u sub, where u will be equal to 2 theta, and the derivative of that will just be 2. For the integral on the right, it will just be theta, as 1 is just a number. Next, we solve the integral on the left, which will just be sine of u, and the integral on the right will just turn to pi over half plus 0. And replacing u with 2 theta, in the next equation, we can finally fully integrate our equation. After a bit of algebra, we solve that the area of a circle is pi r squared, just like we learned in school. Additionally, there's a lot of ways to integrate the quarter of a circle, so if your way doesn't match up with my way, that's great, as long as you get the same answer. You forgot to explain something. It's important. You should probably mention. So some of you may have noticed that I kind of pulled 2 pi r kind of out of thin air when I was explaining the whole visualization of the circle. And I have a reason. The reason is there's a long history about how to get 2 pi r, and there's like this whole battle between nations on who can get the most precise value of pi. But that's a whole video on its own, and I don't want to get into that, but we can. We can. So I hope you understand where the formula for the area of the circle comes from, because now you can calculate this. Additionally, that looks like the Antichrist. So, oh Lord. Oh God, I wish I didn't think